Welcome to my YouTube channel. On this video, I'm going to be programming a sorting station using structured text. So first thing first you do, you make sure that your language is set to structured text. Right, then after here, you right click on device and you add the necessary devices that you need to add. And they are under field bus, under Ethernet, then select the add device, and then click on your added device. Then it will change to show you that you can add more devices. So now we go under Modbus. Okay, something happened there. You can just, all right, I don't know what happened there. Okay, and then click Modbus device there, add. All right, once you are done, go to PLC program, double click on it. Then here you're going to write your variables. Okay, since we have programmed this machine before, I am going to copy the variables from the previous code, which is, these are the variables. Copy them as they are and paste them right there. I want to close the other Codesys. Alright. Then from here, one thing you cannot avoid is the memory latches. So memory coils, I would recommend that you add them here. Add 6 of them. M1 and bull. M0, actually not M1, then bull. So now these are your memory coils. So I said there must be 6. So you copy, enter, paste, enter, paste, enter, paste, enter. Okay, I might have made a mistake. That's 4, 2 remaining, and paste. Right, then do the same with the T timers, T0, N. So this one, I don't have a problem. You can say timer underscore 0. Then it's a TON. It's an on delay timer. Okay, and after here, you have timer 1 here. Okay, here 1, 2, 3, 4. 1, 2, 3, 4, and 5. Just put an extra 1. 6. Okay, then here just add some couple of lines. Right, Now we are starting to write the code. What is our input 1? Or our starting input? This is an area. There's no error actually. Okay. No more errors. Okay. Then now the starting input is this one, I8. I8. So if I8 is on, then our first output Q0 should be on. Colon, then equals to true. Close semicolon, then say end if. Underscore if. That's how it will work. So now, on a normal day, whenever you have an input and an output, whenever you press the input, the output will run for as long as you are pressing the input. And when you let go, it will stop. But now let's test with this, in the case of structured text, how is it going to react? So, check all your settings. There is, say stopped, the system tray, this is your PLC. Then, if there's a need for you to scan for another PLC, you can scan it here. So it looks like the gateway is off, okay, and then the PLC as well is off. Let me confirm, now it's running, so what's the problem? Scan. Okay, there's your PLC there, and the PLC is running. Okay, perfect. Then now we're qualified to download. Then, after downloading, when you see the orange line, you know that you are making progress. Start your PLC on top there. Right, then come here. This I'm just going to ignore. Come this side, press F4. Come to this drop down. Go to Modbus TCP IP. You can just go to configure the counter. I don't want to work with the counter in this example. You'll edit when you want it. And connect. Then there is indeed connection. So what is the basic norm? The norm is when I press the start button, the conveyor belt will move. When I let go, the conveyor belt will stop. I press the start button. Conveyor belt moves. I let go the button, the conveyor belt doesn't stop moving. So meaning that we don't need to latch. So whenever you tell a signal that it starts, it eventually starts indeed. You see, it says true, and it will remain true until you break the signal. So every signal you create, you must always have a way to break it. Otherwise, it's going to create problems for you. press out there. You can still make comments also here and say CB1 start, meaning conveyor 1 start. Entry. Right? Copy out the whole thing. No, I didn't say. Paste. Okay, so now who must be able to stop this? So now when you come to stopping stuff, you stop with the sensor somewhere here, but first we need to honor our stop buttons. So we need to honor our stop buttons. So now the first one is, remember the stop buttons are yellow. We have already passed that stage to say when they're yellow they are on, therefore they are normally closed. So if they are normally closed, this is a condition for normally open, therefore if not, I (10) and 11 there. If not, I (10). Or you can't say N, it must be or I (11). When these two buttons are pressed, any of the two, the stop button and the emergency stop button, when they are pressed at any given time, we are expecting the conveyor forward to stop. So that becomes false here. Delete this part. So you start, you stop, you start, you stop. Download. Let's see. It's running. With the emergency stop button, it stops. With the start button, it stops. So it stops either way. But let's see. Maybe you couldn't see. Start and stop. Now, we'll let it go until we reach a certain point. What happens when we reach that point there? The left entry. I want to throw this away. The left entry. With the small box, look what will happen. The pallet sensor is on and the low level sensor is on. But for this exercise, I prefer starting with the big one. That's just a simple preference. I'm just going to throw away these big boxes and it would be nicer if my stop, if this could be there, because that's where I see a lot of animals. So remember this. Oh, and that must be one group. Okay, I think I would work nicely if this could go that side. Just go. Okay. Somewhere here and somewhere there. Yes, so every time I start my work, I start from here. Yes, perfect. So it will make my life easy. Now look at this. Alert sensor on, low sensor on. When the pallet sensor is on, we want to start the other conveyor belt there. It's called the load conveyor there. I want to start it. And come on the side. This conveyor belt here with the pallet sensor. Copy this, which is your I2 pallet sensor on. And then what is your CB load, conveyor belt load, and then now this one turns on. So to be safe, always put your conveyor your outputs under the stopping functionalities so that you could be able to stop them. So now Q2, because I don't want to act surprised. I know they will have to stop one way or the other. Anything that starts needs to stop. Q6, right? When I2 is on, Q1 is on. It means that this will go forward. But what about the low sensors, low level sensors? Can the low level sensor determine the direction of the transfer chains there? Yes, it can, but you can't decide that there and then say the chain must rise up and go to the side. You won't get any good reaction. Therefore, you need to do it correctly. So when these two sensors are on, which is the low level sensor and the high level sensor, what we want is that we want the signal from them to be carried over and wait until we arrive to I3, this sensor there, I3, which is the loaded sensor there. Then when this sensor here and the memory call that we would have created are now combined, we want the chain to decide whether to go to the right side or to the left side. So for instance, we'll start with the left side. So now when this signal, when this PLC or when this system give us these two signals, we'll carry a memory coil combined with the sensor at loaded, and then we will come to my side here, to my screen, or to the left hand side, right? We'll turn on the transfer chain, and we'll also turn on the conveyor there, this conveyor there. All right, let's do that. Let's do that. So now let's just say now we are dealing with big boxes, send to left. For simplicity, you don't want to complicate your life. So we have, if these two sensors, I0, which is the high level sensor, and I1, which is the low level sensor, if they're both on, then you can't say Q, you need to say M. You're creating a memory signal. M must then be true. That M needs to be able to turn off at some point. It's a permanent signal. It's a latching signal. So when it's a latching signal, we can just say must be turned off. Must be turned off. Like that. We'll see it later. So now we come here. Every signal needs to be able to turn off from using the push button, the stop buttons. So the M's we've already created 6. So 2, 3, 4, 5, 6. Let's say 7. I'm not sure properly the numbering. So 1, 2, 3, 4, 5, and 6. M6, right? You need to be able to turn off all of them. But doesn't mean that you are meeting the requirement that you are not. You are not. So now after that, apologies, the if comes after. Right, so now after that we have this M0, M1. So the signal now, which is M0 and I3 now, are going to turn on Q to the left. Where's your Q going to the left? Every output that goes to your left, you have your CB left, Q5, and Q3 transfer left. So start with the Q3 is true. Copy this. And then Q5 is true. Do you see that? Do you see this? And then, let's see if this will run. So here, we're transporting to the left. I have errors. Okay. colons are an essential part of your programming. And note again. So this one is and is which one is running? Okay, now they are activating. They're activating this. The CB load is activating. So now I want to activate Q0. Look at this. When we reach this point, look there, this conveyor is running. Okay, so now we are having an accident, which is a good thing. Accident is caused by the fact that whenever so you see what happens. That's why we have an emergency stop button, right? Accident is caused by when we reach I3, we need to stop the conveyor Q1, Q0. We didn't stop it. Let's stop it. This error means that Q1 is still running. Q1 is still running. Q0 I mean. So Q0 must stop. CB load. This is your load. And this is your entry, but your stop entry. False. The spelling matters. False. Q0 and 3. Right? Download. Take this away, that away, this away, and observe where it falls. Okay, leave it like this. Okay, so now start. I3 is on, or the signal, we've lost the signal, okay? We've lost the signal that starts the process here. We lost M0, so we need to throw away the boxes. The more distance you open apart, the more you can throw your pallets very far. Right, so now we should be able to alright, let's rather do this. Yep. low level sensor, high level sensor. Look at that. Stop. See? Okay, the other guard that doesn't stop, the conveyor there, it needs to stop as well. It's still running, this conveyor is still running. But luckily we are able to pass. So now let's deal with that conveyor. Let's deal with the conveyor. But that conveyor is not a problem. And now we need to face reality. So you saw what happens now. So how are we going to restart the process there for the box to go inside? Because like that, basically the process has been completed. So we can't restart it afresh. So what we need now is, we need to say, with this sensor, let me go to that sensor that I'm talking about. You see the sensor that says entry left, this one, and it's on, which is this one there, it's active. That sensor, immediately when it senses that the box has just passed by, we want it to say for it to turn on, to turn on this the conveyor here, and also to stop the chain, because at the right moment the chain won't stop. Let me prove you there. The chain won't stop at the current moment. So start. When we reach there, I3, the conveyor belt moves lovely, and the transfer chain see now the transfer chain doesn't stop running even when we pass the stage. The transfer chain doesn't stop, and it has to stop. It doesn't stop. So the sensor there is the one that must stop the transfer chain and must start the conveyor belt there. Right? Let's do that code. So when I3 it's on, Q0 it's off. It's not rocket science to say also Q1 must turn off. Right? Then now we are here. We want to stop the transfer now. Stop the transfer chain. Stop transfer chain. So the process is very easy. To stop the transfer chain, you then write this code. First, write that sensor that must stop the transfer chain. If it's a normally open, if not, and then that sensor is, you see this one at entry to the left, I4. If I4 it's on, then our transfer chain, which is Q3, must turn off. The transfer chain must do what? Must turn off. Okay? But this one I'm not going to demonstrate it. We all know that immediately the box passes there, the sensor will turn on. Then the transfer chain will come back and the box won't pass. I am not going to test that. You can do it in your own spare time, but what I can just tell you is that you need a timer to count for approximately 10 seconds because I've done my homework. We'll make it 8 for argument's sake, then the transfer chain will stop and the conveyor belt this side must start running. So why are we doing it like that? So that we don't have stuff colliding. So we are sure that the box would have passed, or the pallet would have passed this sensor here by the time the time stops running. And then we can now accommodate new complete product. So we are programming this continuously. We are programming this continuously. So let's do that timer now. So now the if not and underscore if copy it, if not I4, we repeat it now. If not I4, when I4 is on, we are expecting M1 to turn on. We're creating what? A timer now. Two. We're creating a timer. Never mind this. This is going to be replaced by the output of the timer. So now the timer goes like this. Timer underscore 0 open bracket. Within the timer, we have a couple of things. We have input. It's that our input is your M1, the one that we just created. To avoid problems, it is best to do that this. You could do through I4, but I don't advise because you would be lacking, the memory latch. So I4 and M1, it's a memory latch. It gives you a guarantee that your timer will run successfully. So you do it like this. Then PT. Equals to T hashtag 8 seconds. Then you close. Like that. Then you put your there. So the timer on input we have M1, which is that, which is a timer latch. Wow, timer latch. Yeah, can call it timer latch. And then now you have your timer which is latched through M1. And then M1 is a permanent signal. It must be turned off and must be turned off. Remember, all your signals, permanent signals, I call them advanced latching. I call them advanced latching. They need to turn off. Okay. Timer 0, M there, you see, PT standard. Then now we want your output. Your output is M. You have done M1. Output is M2. Equals to timer underscore 0, timer 0 dot Q. Then close it like that. So now your output it becomes M2. You see this M2? Your M2 then is the one that turns off. You see? Your M2 turns off your transfer chain. M2 turns it off, right? And then after, it needs to turn on the conveyor belt at entry to continue. After, it must turn on the conveyor belt there. It now needs to bring products again, so it turns it on. So it's gonna come there, R8 or M2 is their job. M2. Now, we said M1 needs to turn on. No, M1, yes, M1 there. M1 here. Needs to turn on, off, I mean. So, who can turn on M1? It's the output signal. It's the output. When Q0 is running, we can turn off M1 because the timer would be on through M1 and it will be on constantly every time, every hour. So we need to be able to turn it off. We turn it off by saying if Q0 is running, then M1 needs to turn off because this is an M1 that is generated by the sensor here. It needs to turn off. So we've checked our first box. We've turned off our first memory coil. And then your M2, when your M2 is on, remember we said again that this must be turned off. How do we turn on that? When M2, look at M2, the signal of M2, where is it generated? It's generated there. And we are having a signal at M0 somewhere here that was created by these two. It needs to turn off. Otherwise, this will always think that we're going left and it will never give a chance to other sections. For the sake of time, I won't demonstrate that part. I will just turn off that signal that was created by these two sensors. Let's turn it off. M2, turn off M0. M0. And this one complains as if there is a problem. Okay, then close it, close it, close it. Close it, close it, close it, close it, close it, and if close it there, on if close it there, and close it there, close it there, and there, and there. I don't see where is the problem. Let's download, it will tell us. if not or not. Okay, there is an error. There are no errors. That's good. All right. Okay. So the signal edge was active. Now we're deactivating it. Then now we're starting the whole process. I'm just going to go where I was. Conveyor is on. We are about to trigger the low level sensor together with the high level sensor. Right, that is on, then the decision is made. Let's go. Okay, the decision to go that side is made, and then the 8 seconds is running. M1, then this M1 must be turned off. M1 is off. Okay, we are failing to go on top. It looks like M0 is true because we are there. I agree with that. M2 is false. I don't have a problem. If Q0 is on, then M1 is false. But M1 is running. Q3 is running. So what happened to this block now? Okay, the Q3 is not turning off. Why is it so? This is Q3. Oh, okay. I'll do this and say that it was supposed to be 3. Confirm it. Transfer left 3. Indeed. Yes. But looks like we are too late for that. We'll have to stop. Hopefully it will allow us. Yes, it does allow us. But it's very close. We need to open a gap in between this. So hopefully, let's throw away the box. And let go. Let's create a gap here, there, and there, and there. All right. Now we have small boxes. You go, because we're not going to benefit anything with you. Right. Okay. And where now it's going? We are going there. Okay, and the decision to go to the left side, it's made. Let's go. Alright, it's working perfectly. So now we'll do the same thing with the right side, because this program, it's not having the right side. It won't go to the right side. Perfect, perfect, perfect. Program is running smooth now. And let's activate. Perfect. Let's stop the program from here. Alright. So we saw the program is running smooth. Everything needs to be done also with what you do to the left side, you need to stop to do it also on the right side. So stop chain transfer, it's on the left. All right. Now, copy. This is very imperative because we are expecting almost the same program. Therefore, you are free to copy and to paste. Then you would say small boxes, and you say right here, right, and you say right. But you need to be very careful because everything changes on the input side and the output. Everything changes. The first one is, let's start it from the top. The signal. We need to create a signal. And so it will be when I0, which is LLS, I can't read it. I0 is HLS. When HLS is on, but we don't want it, so we want to say when LLS is on, which is the low level sensor, and not I1. See, so now with this function, I0 I meant when LLS is on and not the HLS, the high level sensor, then look at this. When this condition is met, it means it will help our I would assume 4, because we already did M1 to 1, 0 and 2. Alright, so now this one's going to be M3. So our M3 must go on when this first condition is met. So because it says and not. So LLS will generate a signal. This is an AND function with a not on it. So with an invert. Those who know my previous videos, they will know that we have dealt with this similar condition before. Alright? So now this condition means that it will prevent I0 and I1 from turning on. Only one of them, when it's on, then it will activate M3. Okay, start it from there. Then go next step. Then when M3 is on now, which needs to come here, when M3 is on and I3 is on, then we need to go to Q4 and Q6, right? Then go down a little bit. Then now, remember here, we had, this is the same as the sensor over there. So that one you don't need to stress. First thing first, you need to make sure that who is being affected. Leave that, will end with it. Otherwise, you're going to be having a problem. Okay, Q3 transfer left. That's the one that we want to stop when with the results of the timer. So it's going to be Q4. And your memory there, M3. You copy what is there on top there. All right, then you go underneath. Then you're having your I4. In this case, you're not going to have I4. You're going to have the entry on the right hand side. Right entry is 6. Right entry is I6. Right, then the memory now you are having right there, it's a memory that must be turned off. Is your M, we did M3, this is your M4. It's your input. And then that input needs to work when this timer under here, which is T1, timer 1. Your input must be 4. That needs to match there. The time is still the same. The timer 1 needs to change. Then M2 must match what is there, similar to what they've done on top. We've dealt with M4, and this one becomes M5. And then this one becomes M5. You must change everything. Otherwise, this will give you some serious problems. Which M1 are we trying to stop? Is the input there, which becomes M4. We want to turn off M4 because that's the one that we said it must turn off, which is the M4, right? And then the signal M3, we said it must turn off also there. That's it there, where it turns off. And then this should be able to go left and right. Let's test it. Download. Any mistake that I could have done will lead to some serious challenges. So now I want to be able to reset any existing program. Start. I knew that something was going to run because the system doesn't forget what was currently running. So you should be able to stop every time. Right? Let go of your switch every time. Your emergency stop, you must let go of it. You must stop it. Right now we have, when start button is pressed, let's go up, visualize our process now. We are over the fence. Let's get the suitable angle, go forward, go on the side, and go down. No, go forward, go down. Yes, and it's going left. As you see, it's going left. And it's bringing more goods. And it's going left again. Now it's bringing smaller goods. And it's going right. Right, then the signal here must turn on the conveyor belt. It's not doing that. the signal over there must turn on the conveyor belt. Let's just fix that. The signal at M5. Or, remember the or M5. When M5, then M3 turns off. Perfect. Let's see. You see, by default, product starts to come in. The timing is very imperative for these not to hit each other, for the products not to hit each other. You can still calibrate it according to your needs. And this is the top view of our product, of our program. And products are running up to infinity, running non-stop. Program looks like this. Feel free to take a good screenshot of it. Every memory coil you turn on, it must be turned off. Every output you turn on, it must be turned off. Then you'll be a happy man or a happy lady. You can take a good screenshot of the program. I'll try to avail it under my description. If it's possible to copy and paste, I'll do it, and I'll make sure that you have the variables that I have used. Okay, and we have an accident for the first time. It's not clear what could have caused the accident. HLS is not active, only the LLS will be active. Then we go to the right. Stop. There is absolutely no need to always turn off your conveyor belts when they're not running, because you can have a mixture of products concurrently running either left or right. Alright, it looks like in some boxes it is best to, they are longer than the 8 seconds. It is best to use 10. It is best to use 10 seconds. When you look at what point they start to stop, they stop running, you can tell that the 8 seconds that is supposed to stop the conveyor belt, it's not enough. Look, it stops it while it's still going. You see? So it's easy for a box not to pass through. So the 8 seconds there, it's small. And it's doing only big boxes. Lovely. Okay guys, I think this is it. Thank you for your support. Keep on supporting me by subscribing. I'll keep on doing content like this. This is beautiful, guys. The only thing I see I'm not able to program at the current moment is how the emitter is releasing the product. But by far, I am very happy. You see, the reason why we can't stop this conveyor belt over here is because, look at this. They will be running concurrently on it. So you can't really decide on that. And immediately a big box is coming. So you can't really turn off the conveyor belt on that other side. Look at that, look at that. This is lovely, guys, this is lovely. I am very happy with this program. Alright, let me turn off the program now.